Hi class. So here is a video for you on running correlation and scatterplot in Microsoft Excel. Again, I am only using this because that's what I have access to at home. But if you have SPSS, there are plenty of videos out there that will show you the step-by-step process for SPSS or any other software that you have access to for statistical analysis. Okay, so I know you don't have your own data yet, so I'm going to, this is already posted in your weekly module, so you'll have access to this example data set. Once you do your surveys, Google Forms will actually have the answers to each item, but remember that the answers to those questions or items that you're asking, although it can total up to a score for that variable, you might still have to reverse score some of those items, right? So make sure that you do that before you run your data. Everyone will be running data correlation, correlation on data for your two main variables, but go ahead and use this data set for practice for right now. Okay, so this is the same data set that I used in a previous video that I showed you. It's the only data set that I uploaded for you, so you should have the exact same one. If you're using Excel like me, be sure to have the tool pack installed. I talked a little bit about this in the last video on how to run descriptives. So just to let you double check, here on, I don't know what this is called, our menu, I guess. If you go and click on data, click it, double click it, I guess, and you look all the way over to the right. Again, if you're using a smaller screen, you might have to scroll all the way to the right, and it should be at the very end. So this is something that you have to add in. It's not something that automatically appears on Excel unless you go in and add it in. It's there, but it's just not added in yet, kind of like one of those settings that you have to apply. Anyways, so click on the data tab. We already talked about that, just a recap. Click on the data tab and then come over here to data analysis, make sure that it is there. So when you run a correlation between two variables, be sure that in Excel, they are side by side. Okay, so I just want to make sure that you can see the headers. Okay, so make sure that they're side by side, otherwise you won't be able to run a correlation. The other thing that you should double check is to make sure that you're only running correlation on numerical data. So you cannot use this where it says gender and then it has F and M for the answers or responses. Okay, so let's run a correlation on these two main variables. This one is the self-esteem scale, and this one is a narcissism scale. So Rosenberg self-esteem scale, narcissism personality inventory. So in order to do this, wait, why does it keep disappearing? Okay, so click on data, and then you want to go over to data analysis, click on data analysis, and here it's in alphabetical order, so the different type of analysis tools, and you're going to go into correlation. So of course, there's like different types, and then there's Pearson product moment. That's the one that we're doing, but for now, it's just going to be under C for correlation, not under P. Click OK. And then with this input range, when you see that it is flickering like they're not there, it means it wants you to select your variables. So what you'll do is, what I do is I go and I click the letters in the column. So some people will like to click on the actual boxes and then drag down. I don't like doing that. I just like making sure that I have all the information. And the best way to do that is to click and drag and then let go. So after you do that, you're going to select labels in the first row. So I like to have my information in columns. If you do it in a different way, if you actually go by rows instead, you're going to select rows. but this is what makes the most sense to me organizationally. You're going to also click labels in first row. This is for if you have organized by columns or rows, as long as your labels are in that first row or column. And then you collect, actually, I'm not really sure about that, but labels in the first row would work for columns. I don't know what it would say because I never use rows. So now you're going to click OK. And here you have your correlation. So a good thing to do just to make everything neat and tidy is to get rid of anything that has that is a duplicate. So here I would get rid of, I'm just going to delete it. And then up here, I would get rid of Rosenberg self-esteem. Click. And then also get rid of the ones. You don't need that. Get rid of one. And that's how we clean our output. Okay, so what you're seeing is this one box that has a decimal. If you know that, if you have a decimal for your correlation, that is likely you've done it right. You cannot have anything beyond positive or -1 in correlations. So if you remember from statistics, it has to be between -1 to +1. Very rarely in nature or even in like data analysis, you'll see something with a perfect positive or negative correlation. So it should be a decimal. I mean, it could be a 1.0 or -1.0, but again, that is something that is really, really rare. Okay, so what does this number tell us? A few different things. So when you have spoken to, when you were probably listening in like to statistics, you've probably learned a little bit about what these numbers mean, but here you'll see that there is no subtraction or negative sign, so you know that this is a positive correlation. Not just that, 0.7 means that it's pretty strong. Now, in research methods, what is considered strong is 0.5 or above, and that goes for positive and negative. So if you have something like a -0.6 correlation, that is still considered strong. When you report this in your paper, your project, you're going to write R, so lowercase r, and then equals, just kidding, sorry, when you're reporting this in your written format, it's going to be R and then parentheses, degrees of freedom, parentheses, equals 0.70 and then 2, since we're rounding. Sorry, I'm going off the top of my head. I really should write notes down when I do this stuff. But anyways, when you put your statistics, you don't include the 0 before the decimal. So it's just going to be point whatever the numbers after the decimals are. I know I told you in a previous video or even in class to only round to 2 decimals after, but when you're reporting, you do want to include 3 decimals over. So that just gives the reader more information. However, if you're using that in your data, it could mess things up a little bit. So this is where you would add 3 values after, or include 3 values after the decimal point. Okay, so you probably have kind of an idea of what this may look like, but if you have something like I have, which is this condition called antiphasia, I can't actually imagine. So what helps people like me are scatter plots or things that are visual to make sense of the numerical types of numbers. Everyone has to include a scatter plot along with your correlation. So for your final project, your term project, you're going to have written out your correlation, but you're also going to include a scatter plot. The scatter plot will go in the appendixes after, or sorry, appendices, I believe that's how you say it, after all that other information. So there is a part for figures, but I believe I told you in class that sometimes this can mess up your format, and I don't want you to, you know, at all mess up the format that you've worked so hard over the course of the term to perfect. So just add it at the end where it will likely not mess up any of your margins or any of the formatting that you've worked so hard to do. Okay, so how do you create a scatter plot? Let's go back to your data. So it should be down here in Excel, data for analysis. And then you're going to first actually grab your data. This is why it's important to have it side by side. When you do this in Excel, you are actually able to manipulate your data according to where it's located. So if you wanted to actually put age right next to narcissism, then you could put it next to each other and have it that way. If you wanted narcissism to be next to, well, these are the only options I have. You can't do narcissism and gender for a correlation, since gender is qualitative and not quantitative. Okay, so first grab your data. We're just going to grab C and D, since that's where self-esteem and narcissism, our constructs, are. And then from here, you're going to go to insert. So this insert tab up here. I know I call it a tab. They used to look like tabs. They don't anymore, but this is still a tab. So click on the tab that is labeled insert. And then all these tools pop down towards the middle. Yours could be, depending on the different types of add-ins and apps you have, yours will likely be around the same area where it says charts. So under charts, you're gonna see, or you're gonna look for something that actually looks like a scatter plot. So that's this one up here. It is like a 90-degree angle that represents a graph, and then some dots that represents a scatter plot. So go ahead and click on this button. And then you're gonna have a drop-down menu. And from all your selections, you're going to click the first one. The first one does not have any lines. It is just a regular scatter plot with dots. And then go ahead and even before I clicked on it, it's already appeared right here, right? So go ahead and click on this. And that is your scatter plot. You can move this anywhere you want. You could have it up here. You can actually make it bigger or smaller. Again, whatever you have room for in your paper, right? So I think I'm going to actually have you turn in a scatter plot just to make sure that you know how to do it, that you've gone through the steps. I know that you already know how to do it from stats, but it doesn't hurt to practice with this play data before you have your own data. So that might be an assignment that I have you turn in just for a few points, or if you do it in class and you can show me how, I'll check it off for you in class. So here, without a line, you can kind of tell that there's a trend, right? And from the correlation that we ran, you know that this is 0.70, what was it? I think it was, let's go look at that sheet. 0.702, right? So that's 0.702. Now, if it was negative 0.702, then it would kind of go this way, but it's positive. So it follows this positive correlation of this trend going upwards. If you're looking at this, you'll notice that these dots, if you hover right above them, it'll actually tell you which participant it represents. So here, hovering on this one, it says series narcissistic personality, NPI 0.2435. So the NPI narcissism scale is 24. You'll go through and kind of look up where 24 is. It might be further down. I might have missed it because I'm not really paying attention. But anyways, that's weird. If I click on it, will it show up? That's a different one, right? Well, I'm not gonna mess with that. So basically, if you hover above, I don't even really know what I did. Let me just click out of there and then come back. Okay, well, it went away. But I want to point out some more tips to kind of help you out. If you find that this is actually pretty clean data, this looks great, I don't see any outliers. However, if you do see an outlier, you might want to get rid of that. That is not considered unethical. It's not considered cheating because you're not making up data to help your the strength of your correlation. But if you find that like sometimes there is a value or a participant who has like a dot up here and it doesn't fit this overall type of relationship of what you'd actually see between narcissism and self-esteem, then you could actually go to that one that sticks out. You'll find it likely by seeing the point. So this one says 11 and 13. This will be easier to find. So here, if you're going through, okay, so here, 11 and 13, right? You could even tell by looking between, so this participant right here, they'll be between 10 and 15 for narcissism, and then they'll be between 10 and 20. So there would be like 2. But if we're looking at this one, you know that this one is 11 on narcissism and then 13 on self-esteem. And then you could actually get rid of that one. However, there's none in here that you probably want to get rid of. With your own data, it might just be due to reasons such as a person was going through your survey really quickly and they did not answer as truthfully, or they didn't read the reverse coded ones very carefully and might have just kind of didn't really care too much to answer that survey. They might have wanted to just get some extra credit because they know that I'm giving extra credit regardless of having the answers to their responses tied to their names. So there's just a few different reasons for that. We actually count on that happening in actual data analysis when we do this out in the field. So it's okay. You can check with me first, of course, but you want to save all your data until you're pretty sure that that was like an invalid response. Also, since you have age, right? Here, this data was already cleaned, but if you have somebody who responded to your survey and they're like 16 years old, we are not taking any minors. So even though they completed everything, you'll still have to get rid of that participant's responses anyways. Most of you will have more than enough participants if you do this on time. I've only ever had like one student say they had something like 27 respondents, but that was because it was really difficult in that year to actually get respondents, since they actually had to go to classes and offer this as extra credit. So you probably won't have that issue. You only need 30 participants, but I would say to collect 40, maybe even 50, just in case there are some of those outliers or respondents that didn't really answer truthfully. And then after that, since this will be on Google, you can close your surveys so that people cannot continue to answer. Sometimes if you don't close your surveys, it's open for a while, and people who are like last minute trying to get extra credit or something like that, they'll go through it really fast, and that can actually mess up your data if you've already run your statistics. So that's all I wanted to say for this presentation. I know I mentioned in class, I'm doing this video for both people who are asynchronous, but also for those of you who are in face-to-face class, so that you can ask me. Either way, any of you can ask me questions. You can email me, set up a Zoom office hour meeting, and we could talk more about this. But otherwise, I hope that was helpful for you to see, and hopefully now all that stuff that you learned from statistics is coming together to make sense, using it, applying it in a almost more real world situation. All right, have a good one. I will talk to you soon.